So our next problem is to find the product of x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. So we will be following the same thing, these steps here. So we need to factor out the numerators and denominators. X plus 2, you cannot factor that out. So we have x plus 2 over. Now, if you try to examine this, x cubed minus 27, okay, this is actually um, a difference, or this is a difference of two cubic numbers. How do I know? Because x is cubed. Now 27, can I express that as cubic number? Yes, I can do that. So to express that as cubic number, I can rewrite that as x cubed minus the cubic form of 27 is 3 cubed. 3 times 3 is 9. 9 times 3 is 27. Times, so if you try to see here, we don't have here at the denominator. So to, ex to express that as fraction or rational function, we can write that as x squared plus 3x plus 9 over 1. The denominator will always be 1. Now, going back to the denominator here, we have a rule before, so we learned this in our second quarter lesson about cubic numbers. So what do you know about cubic numbers? So we have a format of a cubed minus b cubed. So a and b are cubic numbers. If you want to factor that out, we have a pattern, and the pattern is the difference of a and b. A and b are integers, okay? Integers, or they can be variables, times a squared plus the product of a and b plus squared d. So in that case, we can follow that pattern. So in our problem, our a is x, our b is negative or 3. Okay, we disregard the sign. Okay, to expand that or to factor that out, first thing we need to copy that x plus 2. By the way, we are placing it in a single fraction sign, so we can easily divide out the common factors. So to do the denominator, which is the difference of two cubic numbers, we would just plug in here our a and b. Our a is x, so a minus b, so we have here x. Our b is 3 minus 3. Multiply that by a squared, so that's our a is x, so we have x squared plus the product of a and b, or a is x and b is 3, so 3 times x, that is 3x. B squared, our b is 3, so what is 3 squared? That is 9 times 1, so we don't need to place that 1 anymore. Next, so if you try to see here, you don't need to actually factor that out because we have here common factor. They are common, so you don't need to factor that out. So just copy your numerator in your other factor, which is x squared plus 3x plus 9. So from there, you can easily factor out or divide out our common factors, which are here and here. Okay, so now we are left with x plus 2 over x minus 3. So this is now our simplified form. Now regarding step 3, which exclude the restricted value for x. Now notice that here the denominator, the factor in the denominator that we get, which is x squared plus 3x plus 9, does not equal to 0 for any real values of x. So what do we mean by that? So meaning whatever value are we going to place in exchange of x here, it will never be equal to 0. So it means that no values must be excluded from the domain to make the simplified form, which is x plus 2 over x minus 3, equivalent to the original expression, which is the given. In that case, for this problem, there will be no excluded value. Now, to counter check our claim that x squared plus 3x plus 9 doesn't have a 0 or it will not be equal to 0, let's try to check the graph. So let's graph x squared plus 3x plus 9. So if you try to see the graph of x squared plus 3x plus 9, it doesn't intersect the x-axis. So what do we mean by that? So we don't have any x-intercepts. And what do you know about x-intercepts? They are your zeros. They are your solutions. So meaning x squared plus 3x doesn't have any solution because it doesn't have any x-intercept in its graph over here. So that's how to counter check our claim.